The Dark Energy Survey is a Southern Hemisphere observation project designed to probe the acceleration of the universe by looking at the most distant galaxies. But since it started peering into the sky 3 years ago, the project has proved surprisingly useful for answering mysteries much closer to home. The evidence for a ninth planet in our solar system might be hiding in data gathered as part of the survey, and if so it could be found by the end of summer, an expert told in January. Caltech astronomers Professor Konstantin Bodian and Professor Mike Brown predicted the existence of what they, somewhat controversially, termed Planet 9. They used mathematical modeling and computer simulations to find the planet would exactly explain a strange clumping behavior of a group of dwarf planets in the Kuiper Belt, a field of icy objects and debris beyond Neptune. The unknown world, dubbed Planet X by others, is thought to be 10 times more massive than Earth and the furthest planet from the Sun, but its exact location is unknown. Since the prediction, researchers over the world have been using different instruments to hone in on the planet. And the results pointed to an unexpected part of the sky, the part DES has been inspecting for the last 2.5 years. I fell into the search for Planet 9 almost by accident, member of DES Professor David Zerds, from the University of Michigan, told Mail Online. Professor Zerds said he was looking for a project to give his students when Planet 9 was brought to his attention. A team of French researchers used data from NASA's Cassini spacecraft orbiting Saturn, looking at the distance between Saturn and Earth, to narrow down where the planet could be in a paper published in March. The predictions in this, and the original paper published in January, mean DES might have been looking in exactly the right place to spot the mysterious world. If it was, the planet could be found as soon as by the end of the summer, Professor Zerds told Mail Online. At the moment Professor Zerds and his team are going through a process of cataloging the objects that have been spotted so far. Most of the area of the sky that will be looked at has been surveyed so far, so if the planet is there and in the right part of its orbit, it should be hiding in the data. But not finding it does not mean Planet 9 does not exist. If we see it, it's a great result and a fun paper to write, he said. If we don't see it, the challenge is working out exactly what that means. Not spotting the world would mean a lot more constraints could be placed on the model, helping other searches potentially track the planet down. But spotting it directly is not the only way to tell if it is there. The paper published in January made a series of predictions, with consequences that can themselves be observed. For example, the paper predicted 6 objects in the solar system that would be perfectly aligned, and one of these has already been found using DES data. A population of minor planets that cross the orbit of the giant planets in our solar system, which might be found independent of the search for Planet 9. The orbit of any of these objects could be used to place more constraints on the location of the planet. The use of the Dark Energy Survey was by chance, but was not necessarily surprising. The 5-year survey is helping astronomers find out exactly what dark energy is made of. They are doing this by analyzing very distant galaxies over long periods of time, to watch for objects moving very slowly, which is why the project takes such a long time. This is why the survey is the perfect opportunity for lots of other science to be done at the same time. The data from survey has led to the discovery of companion galaxies to our Milky Way. Famous companion galaxies like the Large Magellanic Cloud can be seen easily from Earth and are well known because of it, but many more have been spotted by the DES camera. DES doesn't just tell us about cosmology. It also tells us about the origins and contents of our own solar system. Dr. Kathy Romer, member of the Dark Energy Survey from the University of Sussex told by chance, rather than by design, DES has turned out to be a great way to find new examples of dwarf planets orbiting the Sun. After starting in 2013, the scientists are now over halfway into the 5 years they set out for the project. The main aim of the experiment, which involves hundreds of scientists, is to come up with an equation that describes the behavior of the mysterious force known as dark energy. Dark energy is a phrase used by physicists to describe a mysterious something that is causing unusual things to happen in the universe. The universe is not only expanding, but it is expanding faster and faster as time goes by, Dr. Romer said. What we'd expect is that the expansion would get slower and slower as time goes by, because it has been nearly 14 billion years since the Big Bang. Coming up with an equation of state would give the researchers clues about what is making up this mysterious force. At the moment, the favorite candidate is called the cosmological constant, which has a relatively boring equation of state. But, despite its simplicity, the cosmological constant is not the something that scientists are hoping for, Dr. Romer said. A cosmological constant then messes up other parts of physics. It's like a table plan at a wedding. You think you've got it all sorted out, and then you notice that, because the caterers gave you a round table instead of a long one, your dad is now going to be sitting next to your mom's new boyfriend.